Several values of two functions f and g are listed in the following table, shown here. If possible, find f of g of 6, g of f of 6, and so on. Let's do f of g of 6 first. By definition, this means f evaluated at g of 6. Let's see if the table gives us a value for g of 6. 6 is the x value, the input to the function, so if we scroll over to 6 and go down to the row corresponding to g of x, we see that g of 6 is 8. So this now says f of 8, making that substitution. Let's go back to the table and see if f of 8 is defined. Go over to 8 along x's row and find out the value of f by looking in the first row. We see that f of 8 is equal to 5, and so the answer is 5. That tells me that f composed with g, that new function, has a value of 5 when we look at x equals 6. Let's try the second one. G composed with f of 6. That means g evaluated at f of 6. Let's see. F of 6 from the table is 7. So we now have g of 7. And looking at the row in the table, the first row in the table for x, we see that 7 is in there, and g of 7 is equal to 6, and so our answer is 6 in this case. Continuing, f of 6 means we evaluate f at the value of f of 6. Well, f of 6 is 7, so now we have to do f of 7. Go to the table, look at 7, row 2 gives us the values of f, and that's a 6. So f of 7 is equal to 6, and that gives me the value of f of 6 as well. How about g of 6? Well, g of 6 in the table is 8, so we have g of 8. Again, back to the table, if we scroll over to 8 and go down to g, we see that g of 8 is equal to 5, and the answer is 5 in this case. And lastly, f of g of 9 means take the value of g of 9 and feed that into f's inputs. G of 9 from the table is 4, so we need to evaluate f of 4. Now we can go to the table, try to find an input for 4, and we find out that is not possible. 4 is not in the domain of the two functions that are listed, or at least we are not shown the value of 4 if it indeed does exist. So I'm just going to write not available. F of 4 is not in the table, and so we don't have enough information to answer that question. The tables can be a useful way to trace through values and learn a little bit more about how these compositions of two functions really are behaving point by point.